of actual working functional code they're developing. And if they commit more work than could be done in an hour, then I said to them, look, that's a concern, right? I want to know that you are actually doing this. And if you've grabbed a whole bunch of stuff, you can commit that, but you tell me this is from here, right? You cite it if you commit more than what you would be able to do now, right? So every hour you do a meaningful commit message, and I will include the content of your commit messages as part of your exam process. Right? So your commit messages should tell me what you are currently doing, what you're currently working on, what problems you have every hour that you do new work. Which means, if you want to go to sleep for 3 hours and then do an hour's worth of work, then there's a 4-hour gap between commits. That's fine. But the content of the commit is 1 hour of work. Although I required them to commit every hour, they only need to push somewhat regularly, right? So every couple of hours was fine to push to the shared repo. But because all of the commits are hashed and time-stamped and things, that you can still see when they were doing work. And they document the exam questions. So I have a couple of questions. I also asked them, how did they do this, and when did they, and how did they solve this problem? As a couple of questions. They do the documentation in the README of the repo. Right? So that's where they write any kind of written content goes in there. Because I have a small class and I also want to check to see how this works, I have a 10-minute oral discussion with the students about 48 hours after the exam. Right? So they do the exam, they go away, they sleep, they come back, and they have this 10 minutes, and I just quiz them a little bit about how they did things and basically confirm that it truly was actually them that wrote all that code. Okay, so that was my process for the GPU students. In the short discussion, I gave them a link to a research poster on Huff transforms, and I asked them to discuss that. And I asked them what were the challenges you faced when you were developing the solution. And so they have to discuss how they came up. So a Huff transform, this is an example of how it does is you can have a bunch of edge detected circles, and you find the center of those circles. Right? So that's a way of doing circle detection. Right? So that was the task. They'd never seen it before, so they also had to learn the math in the 24 hours to do it as well. So, but there are examples online of the linear Huff transforms, not so many of the circular Huff transforms. So document the README. Now, of those 10 students, we had 1A, 2 Bs, 3 Cs, and 3 Ds were my grading from their work, and 1 F who looked at it and decided no, it's too hard, and didn't actually do the exam at all. No? So people who actually went through and committed stuff had a reasonable distribution. I talked to the students, and of the 10 in total, so I didn't talk to this guy because he didn't show up to the oral either. But after the discussion, I asked, and 6 of them out of the 10, so kind of, said that it worked very well for them, right? So this gave a good indication of their ability. 8 of the 10, so one guy went, I don't really care about exams. But the other 8 felt that this was better than normal exams, right? They felt more confident that it gave a good reflection of their ability to program and to do GPU programming than doing stuff on paper and essay-style written exams. So the students liked this format better than traditional exams. Now, that doesn't mean it's actually better than traditional exams. It just means the students like it, which could mean that it's worse. Now, so from Bitbucket, you can get things like you can go and quickly scan their commits, right? And so this was a standard typical one of the students here. During the time, they actually give you the time of these commits, but I'm looking back into the past now, so they're just giving you the date that they haven't. But that's the order in which they came in. The new kernel extracts parallelism by having half the block size per pixel, much lower than limiting the radius to 15. So this is him documenting his experimentation on trying to improve the speed and efficiency on the GPU of this task. Now I can see that, and then I can click in here and go straight to the piece of code that he was editing and see the changes that he was making. Right? So for me, I don't have to kind of work out how the process is being documented. And you can see this is, you can't see, this is what you can't see there is is the standard Atlassian. These are the files he edited, and this is an example of the file and showing you where the lines of code were added in context, right? So it's the standard way of visualizing Git, and a very quick way for me to dig into the code and see what the student was actually working on at that point. So the graphics exam, so that was for semester 6 students. So these guys have been using Git regularly. My graphics students in 2015, so just last semester, we introduced using Git to share code throughout the semester, and then I had them do the 72-hour take-home exam. I've run this for 5 years, so we've used 5 years of 72-hour take-home exams. This was the first time I tried this Git as the way of running it process. And again, a similar process, but this time I created a repo with more actual code samples in it for reading some of the text files, which I considered non-graphic specific. They were reading in a PNG file. I gave out the exam task both in PDF on Fronter and as the description in the repository. So they had the exam description in the README of the repository. I had in my core repo the Q&A section. So 72 hours, students are going to come with questions. And I said, and my process was, I will not answer questions directly from students. If you ask me a question, I will write it in the core repository. I'll write the question and I'll write the answer there. And because they have forked the repo, they automatically are watching the repo, which means when I update my repo, they all get an email saying, oh, this repo has been updated. You should go and have a look at it. Right? So the Q&A kind of are automatically updated on whenever those change. We also, to improve our ability to make sure the students were creating code we could run and test, 24 hours in, we had a optional commit where we would compile and run that commit just to make sure that we could pull it, compile it, it would run. Right? Just check your libraries were all included properly and you included your core files. Right? So that was the process there. This time, so if we had 20 students, 16 of them actually felt that it was so that was good. They all preferred. So these were the semester 3. They all said this was much better than trying to do stuff on paper. And the 4 that failed actually never pulled the repo. They did assignment 1 in the course. Some of them started assignment 2, but by the time they got the exam, they'd kind of given up. So they dropped off the back. What the students said is that in those 72 hours, they learned an enormous amount because they just allocated time to this one thing. It's all they did. And because they had like a large motivation to do it, this is where they actually learned to do graphics more than necessarily in a lot of the other material, which it's irritating that they waited till the end of the course to learn, but it still had a very strong learning outcome according to the students. 72 hours is a hard exam to set, right? Because you've got to think it's going to be 3 days, so that's 24 to 30 hours worth of work for an average student over a 72-hour period, right? Because I'm not gonna make them do 72 hours work in 72 hours. That's ridiculous. But of course, the very, very best student will do that faster than the average student. So the first student was done with all these exam tasks within the first 14 hours. He then spent another about 40 hours of the 72 improving his results and improving his code and doing all sorts of things that I hadn't asked him to do. And for this, what I say to the students is, I give them an example. So in the exam, I give them an example of what they are required to do. Right? You do everything you're required to, you get a C. I give them examples of things they could do in addition to that, which start them moving into the B grade. And then I say for A, you have to do something else. And I cannot tell you what it is, because if I tell you what it is, it's no longer independent thinking. So I say to them, look, you want an A, you just have to do more. I don't know what it is, just more. And so the students who did finish early, they just kept working on it because they want their A. And it's harder to limit them and say, okay, no, you're done now, just go away, stop working. So they did some amazing things, added massive, so the assignment this time was block world. So basically like Minecraft. So you get a height map and you are to build quads, build the cubes, texture them, change the texturing by height, put in a sun map and change the scale in by doing it in the shader. So you had to do shader programming. And some of them added rain, and they added voids, and they had texture generation, and yeah, they just went crazy once they got the task done. Now, again, a small number of students, so this is actually relatively easy just to hand scan over. You can use other tools. So Git Inspector is an interesting tool. It's open source, which means you can edit it, and it allows you to inspect the Git repository to see when things were being committed and how much it was, and actually because Git Inspector was created by Groningen, by Chalmers, I think. They have a minus grading mode in it. It was specifically designed to be used as a stat tester for Git repos for assignment grading. So it actually has a whole bunch of stats on, down here it's warning me that one of the files is too complex. Right? So it seems to be too complex and too large, and that should be something I should look at. And the two different variations you see here is because I have some commits and code in the beginning, the small wedge was me, and the rest is the students adding of work. So you get to see the ratio of how much they're using from the original material. And that allows me to visualize the tools. For the evaluation, I scan the commit messages, I scan the code. So when I see an interesting commit, I go and have a look, see what they changed. I read the answers to the questions, and I pull the repo. For quality of code, I'm looking at clarity. I look at the comments from the point of view of if I was trying to debug this code, would this comment help me find the error? Right? So that's what I say is the most important, is to commit to help. So your comments should help someone trying to debug your code. And I want to use those commit messages to understand the challenges you have, right? Because they get, in the repo, they get attached to lines of code. Your commit messages tell you what was being solved by that line of code when you look at the line of code, when you look at the code at the end. So students like the exams, this side. The middle students learn a lot. The top end students just play. The bottom end students struggle. The middle students learn a lot. The oral component needs to be removed for large classes, so I'm trying to work out how I remove the oral component. And I've got an idea for that, where you have a Google Hangout, and I announce the questions in one go to everybody who's watching the stream, and they all have to write into the repository their answers and commit them immediately. That way I get to see everyone's at least sitting there and typing simultaneously to answer that question, and they all commit instantly, which means I can then go back over and check those answers later. So that allows me to kind of distribute that question. And I need to automate more of my the repository inspection tools, which is why I'm looking at Git Inspector, because if we move to larger classes, you can't manually inspect everything, so you need to highlight what's important. Okay, so that was me.
I have time for two small questions, if there are.
I use 21 minutes. So.
Be careful though, because I'm just
Yeah, right. Be nice to me, or are we?
I was thinking about, I mean, first it was really interesting. And this issue of what it is that we are peeking into when we evaluate what the students are doing. Because I think there is a balance here. There is some line where if we go too far, I think we are being invasive. We're requiring to know every time the student made some mistake and corrected it, and the sort of way needed to get to the solution. Now, in the case of commits, they are anyway a type of comment that you would share with your team when you do programming, so they're in a way official stuff. So you're on the right side. I think there are limits to how much we should require to know about when this poor student is sitting for 72 hours having some process. So
learning process. Yeah. So one of the things we had looked at was screen capture, and whether you do 1 second screen capture and then create a video of your process. And at that point, it might be considered invasive, right? That might be on the other side when you know the computer is watching everything you do. Then that might be that's kind of on the other side. So that requires quite a lot of working out as to what's appropriate. But there is a level of invasive. I did discuss this, right? This was in my mind when I was looking at how much we should be recording and how long between commits, right? So. And I felt an hour during an exam was okay, and it's just during the exam, so it's not every day all the time you're being sort of monitored. Yeah, but it's one of those challenges of he's got yeah. How much should you monitor? Now, one of the things we are working on is actually getting students to share code with each other, because they're quite hesitant to show off their bad code, right? Because I don't want to show it yet. And so we work quite hard on trying to create a communal environment where we share code and we accept that code will look bad when you first write it. And so we expect the students to be sharing code with each other, and we expect them to do code reviews of each other's work. And so we try and create that environment where sharing what you do and commenting on what you do is considered the norm. And so we do group work. Most of our projects, almost all of them, are group assignments, just to encourage that sharing is what we do as programmers.
Okay, thank you.